Hello everyone. This is Mrs. Padmashri from SNS College of Engineering. Today we are going to discuss the topic Resnet architecture in convolution neural network. The Resnet is called as Residual Network. Is a very famous deep learning neural network model mainly used for computer vision application. It is mainly used in GPU, graphical processing unit GPU. So, as this architecture, which is the continuation of the previous topic, the AlexNet architecture. So, both the architecture comes under the convolution neural network architecture. So, the main purpose of convolution neural network architecture is mainly used to process the pixel data. And we are going to use a different type of architecture. When we compare each and every one, the other one will be the best one. By this can be validated by understanding the performance, by improving the performance of neural network. So, as I said, it's mainly used for computer vision application. Say, for example, we can take facial recognition, autonomous vehicle system. Like nowadays, we have autonomous vehicle system. Like we don't have the driver to drive. We don't need the driver to drive the car. So automatically, the car will be drive by AI system. So these types of architectures are used there, like facial recognition, autonomous vehicles, medical imaging, all these fields we are using this kind of convolution neural network. And so this teaches the computers to recognize, to interpret the visual information. So mainly the convolution neural network architecture is designed to support, it is designed to support the hundreds or thousands of convolution layers. So mainly we have uh, we have several layers are present in the convolution layer. So the ResNet in short residual network, it's a type of neural network which is introduced in 2015, mainly used to solve the problem of vanishing gradient problem. So in this introduction lecture, we just learn, or we just understand why this ResNet architecture is evolved, why we use this Resnet architecture. And in the next lecture, next session, I will be explaining you the detailed architecture. Okay, so residual network, neural network, it is mainly introduced for vanishing gradient, to solve vanishing gradient problem, mainly introduced to solve vanishing gradient problem. Why this is used? This is mainly it affects the performance of the neural network. Okay, so what is this vanishing problem, and how this ResNet overcomes that problem will be discussed in this further slides. What is this vanishing problem? See, in a neural network, in a convolution neural network, there will be several architectures, and each architecture is designing in the own way. Like it will be having advantage and it will be having drawbacks also. To overcome that, we have so many architectures like AlexNet, ResNet, InceptionNet, VCG, etc. These are all the types of convolution neural network architecture. So mainly this winning architecture, what this name as a winning architecture means, if this ResNet is compared with the AlexNet, the ResNet is a winning architecture. Why? Because it is solving the problem of vanishing gradient problem, or vanishing exploiting problem. Okay, so what many people will not understand, what is this vanishing problem, etc., right? Because see, as I said, the convolution layer will be having many number of layers, like say thousands and 2000s of layer. When you increase the number of layer, there will be a drawback, like it affects the performance of the neural network. So what is the solution? What is the solution, how to handle this? Because neural network in a sense will be having the several layers. So there is increasing the number of layer, we will be having some common problem in deep learning, which is called vanishing exploiting gradient. So this causes a gradient value to become either to become 0 or it could become too large. Okay, so when we increase the number of layer, obviously the training, it takes more time to train the data, one thing, and there will be many test error. It increases the test error. So this, because of both the reasons, it affects the performance of the architecture. So we'll see one by one what is this. So to solve the problem, this architecture residual blocks has come, which is nothing but ResNet. What is this? Rest is called residual blocks. What is this called residual blocks? So when we say the blocks will be like the block which is arranged like this, right? So the same. Here we have a flow, of network. How this network flow is, it flows from one layer to the another layer. Okay, so it works based on the concept called, we use a technique called skip connection. Okay, the skip connection, it connects only the activation layer with the further layer by skipping some of the layers in between. Right? Understand? See, there will be several layer. As we all know, convolution layer, neural network has several layer. So, how to reduce the number of layer? So, in which some layers will be working and some layers will not be working because of so many issues that we will discuss later. Because of so many issues. So, what we need is, we need only the activation layer. So, we will not bother about non-activation layer. Right? Activation means, what is the activation? The layer which conducts, which transmits something, some data, which is alive, which transmits some data to the another layer. So what we do, we will just find out the activation layer, and we will connect only activation layer with the other activation layer. In between, the layer which is not working, not active, or not transmitting anything, that we will skip it. So that many layers are reduced, many layers will be, the number of layers will be reduced. So we can improve the performance of the neural network. This is the concept of ResNet. Okay, so this forms all the working layer forms a residual block together, and the approach began is, instead of instead of layers learning the mapping, what we do, we allow the network to fit into residual mapping. So there are some functions we have. F of x is equal to h of x minus x. So which in turn, if you want to find out the h of x, which will be f of x plus x, is a mathematical computation. So x is the input. So this is a skip connection. So as I said, the architecture follows the skip connection, which is a advantage in the ResNet. So x is the input, the input we are giving to the weight layer. Okay, you know that each neuron transmits something, and each neuron has activation function which checks whether the neuron is alive or not. Okay, and it has a weight assigned to each and every neuron. So input goes to the weight layer, and we know that what is rectified linear unit. What this rectified linear unit does, it transmits the data only if it has a positive value, otherwise it becomes zero. Right? Positive means it transmits them. If it is a zero, which means indirectly the node is dead, or it's not alive, and it is not transmitting anything. So we will skip it. So this activation layer is very important. Reactivation linear, rectified linear unit, which just checks whether the particular node is alive or not. Which, if it is has a positive value, it just transmit. If it is not positive, it just sends a zero. Okay, see, we are just skipping it, and we are just calculating the weight of all the layer. So this is a skip connection. I hope you understand. Input, we are giving input which processes and functions. It just activation function, f of x just checks whether the particular node is active or not. It transmits to the other layer, and it goes to the other layer. Plus x is, it adds the input value, checks the reactivation linear unit. If it is positive, it transmits, it adds, so that it forms a set of blocks like this, which the block which is working condition. And in between, we'll be skipping it. If it is not, if the, suppose here in this part, if the value is not positive, if it is zero, which means it is not transmitting anything. So we will skip that connection. Like, again, the x, we can connect it to the another working layer. So this, what is the advantage? So whatever I have explained is there in this. It allow only the positive value to pass it. and the negative value it will not allow, it will make it as a 0. It helps the neural network to maintain the necessary complexity in order to learn some of the patterns. Okay, and it solves the vanishing gradient problem, and this is described mathematically. As I said, f of x is equal to maximum of 0 comma x. X is input neuron. Function x should be greater than 0. If it is less than 0, it returns the value 0. Right? Advantage of the skip connection, it will not hurt the performance of the network architecture. It just keeps the layers. So this results training a very deep neural network without causing any problem, which in turn improves the performance of the network. The architecture of Resnet will be discussed in the next session. Thank you.